Class 10, Chapter 13, Surface Areas and Volumes, Module 3. Objectives. In this module, you will learn about conversion of solid from one shape to another. Dear children, last class we had discussed surface area of combination of solid and also volume of combination of solids. Now the next one is what? Conversion of solids from one shape to another shape. So listen, a metallic sphere of radius 4.2 centimeter is melted and recast into a shape of cylinder of radius 6 centimeter. Find the height of the cylinder. So listen, the first solid is a sphere. So we need to melt the sphere and recast into a cylinder. So we need to find out the height of the cylinder. Then the given conditions, the radius of the sphere 4.2 centimeter, radius of the cylinder 6 centimeter, and height we need to find out. So listen carefully. If one solid is recast into another form, then the volume of that first one solid is which one? Sphere is equal to volume of the cylinder. Now we can equate that equations. That is 4 by 3 pi r1 cube is equal to pi r2 square h. Now substitute the values. 4 by 3 pi into 4.2 the whole cube is equal to pi into 6 square into h. Now pi and pi are cancelled. So we need to find out the value of h is equal to 4 by 3 into 4.2 into 4.2 into 4.2 divided by 6 into 6, which is equal to 36. Now you can cancel 4 and 36 9 times. Now 3 and 4.2 cancel. 1.4 into 1.4 into 1.4. That is when you divide 4 and 36, 9 is the denominator. So 3 into 3 into 3 become the denominator. When you cancel 4.2 by 3, 1.4. So cube of that is h. Now what is the value? 2.74 centimeter. Okay. So cube root of this 1.4 is equal to what? 2.74 centimeter. Therefore the height of the cylinder so formed will be 2.74 centimeter. Clear? Now in metallic spheres of radius 6 centimeter, 8 centimeter and 10 centimeter respectively are melted to form a single solid sphere. Find the radius of the resulting sphere. Here only one shape is this one, sphere itself. But a metallic sphere of radius 6, 8 and 10 centimeter respectively. So small spheres having the radius 6 centimeter, 8 centimeter and 10 centimeter are melted to form a single solid sphere. It is larger than these three. Find the radius of the resulting sphere. Let the radius of the resulting sphere be r centimeter. We can take it as r centimeter. Then the volume of the resulting sphere is equal to sum of the volume of the three spheres of radius 6 centimeter, 8 centimeter and 10 centimeter. Implies 4 by 3 pi r cube is equal to 4 by 3 pi 6 cube, 4 by 3 pi into 8 cube plus 4 by 3 pi into 10 cube. 4 by 3 pi we can take common factor and cancelled. Remaining r cube is equal to 6 cube 216 plus 8 cube 512 plus 10 cube 1000. Now r cube is equal to 1728. So r cube is equal to 12 cube. So r is equal to 12 centimeter. Now the next question. A 20 meter deep well with a diameter 7 meter is dug and the earth from digging is evenly spread out to form a platform 22 meter by 14 meter. Find the height of the platform. So depth of the well is equal to 20 meter. Radius of the circular end of the well is what? 7 by 2 meter. Now area of the platform is equal to what? Length into breadth. Assume the height of the platform be h. Now the volume of the soil dug from the well will be equal to the volume of the soil scattered on the platform. Now volume of the soil from the well is equal to volume of soil used to make such a platform. So what is the equation? First one, since it is a well cylinder, so pi r square h is equal to area of the platform, length into breadth into height, cuboidal in shape. So pi into 7 by 2 the whole square into height is what? 20, which is given, depth of the well, is equal to length into breadth into height. So 22 into 14 into h. Now h is equal to pi value what? 22 by 7 into 7 by 2 into 7 by 2, which is 49 by 4 into 20. The whole divided by what? 22 into 14 is there. Now cancel 22 and 22. After that 49 7 times. 7 and 14 2 times. Okay, now 2 and 20 10. Then 4 and 10 cancel, 5 by 2. So 5 by 2, which is equal to 2.5 meter. Hence the height of such a platform will be 2.5 meter. Now the next one. A well of diameter 3 meter is dug 14 meter deep. The earth taken out of it has been spread evenly all around it in the shape of a circular ring of width 4 meter to form an embankment. Find the height of the embankment. Now listen carefully to the speaker. Depth of the well is 14 meter. Radius r of the circular end of the well is what? 3 by 2 meter. It is given what? 3 meter is the diameter, so 3 by 2 meter. Now width of the embankment is 4 meter. Then it can be observed that our embankment will be in the cylindrical shape having outer radius. Okay, so listen carefully. The top portion of that is cylindrical portion, which is what? The embankment is this one. Now R1 is equal to 4 plus 3 by 2, which is equal to 11 by 2. That is 3 by 2 is the 3 is the diameter of that cylindrical well. So radius is what? 3 by 2. Plus what width is given? Embankment width is what? 4 given. 4 meter. So add 4 plus what? 3 by 2 is equal to what? 11 by 2 meter. Let height of the embankment be h2. Now volume of the soil dug from the well is equal to volume of the earth. So pi r1 square h1 is equal to pi into, since it is a ring shape, 2 radius are there, inner radius and outer radius. So pi into r2 square minus r1 square into h2. So pi into 3 by 2 the whole square into 14 is equal to pi into 11 by 2 the whole square minus 3 by 2 the whole square into h2. So pi and pi are cancelled. Now 3 by 2 the whole square become 9 by 4 into 14 is equal to 11 square 121 minus 3 square 9. So when you subtract it, what? 112 by 2 square is the denominator. So 2 square, 2 into 2 is equal to what? 4 is that. Okay. Now into h. Now h2 is equal to cross multiply 9 into 14 into 4 divided by 4 into 112. Now 4 and 4 are cancelled. 14 and 112 8 times. So h2 is equal to 9 by 8, which is equal to 1.125 meter. Thus the height of the embankment will be 1.125 meter. Now a container shaped like a right circular cylinder having diameter 12 centimeter and height 15 centimeter is full of ice cream. The ice cream is to be filled into cones of height 12 centimeter and diameter 6 meter, having a hemispherical shape on the top. Find the number of such cones which can be filled with the ice cream. Now let H1 of the cylinder contain, that is 15 centimeter height of the cylinder. Radius is equal to diameter by 2. So radius outer end of the container is 12 by 2, 6 centimeter. Radius R2 of the circular end of the ice cream cone is equal to 6 by 2, 3 centimeter. Height H2 of the conical part of the ice cream cone is equal to what? 12 centimeter. Let n ice cream cones be filled with the ice cream of the container. Volume of the ice cream in the container cylinder is equal to n into volume of one ice cream cone plus volume of a hemispherical shape on the top. So, pi r1 square into h1 is equal to n into 1 by 3 pi r2 square h2 plus 2 by 3 pi r2 cube. So, pi into r square into 15 is equal to n into 1 by 3 pi into 3 square plus into 12 pi r2 square into h2. So 3 square into 12 plus 2 by 3 pi into r cube, 3 cube is there. Now pi into 6 square into 15 is equal to n into 1 by 3 into pi into 3 square remaining. Pi we take it as a common. 3 square into 12 plus 2 into 3 cube. Now 6 into 6 into 5. Pi and pi are cancelled. N into 3 square. We can take it common factor from the two terms. So 3 square by 3 into remaining first term 12 plus 2 into 3. Now 6 into 6 into 15 is equal to n into 3 square and 3 are cancelled, remaining 3. So 3 into 18. So n is equal to 6 into 6 into 15 by 3 into 18. Now cancel 3 and 15. How much time? 5 times. Now 6 and 18. 3 times. 6 and 3. 2 times. So 5 into 2 is equal to what? 10. Now n is equal to what? 10. That is 10 ice cream cones can be filled with the ice cream in the container. Now how many silver coins? 1.75 centimeter in diameter and of thickness 2 millimeter must be melted to form a cuboid of dimension 5.5 centimeter by 10 centimeter by 3.5 centimeter. So how many silver coins? So coin, suppose it is, what is the shape? Cylinder filled with 1.75 centimeter in diameter and of thickness 2 millimeter must be melted to form a cuboid. So H1 height of the cylindrical coin is equal to 2 millimeter, which is equal to 0.2 meter. Radius of the circular end of the coin is equal to 1.75 by 2 is equal to 0.875 centimeter. Let X coins be melted to form the required cuboid. So volume of the cones, X cone is equal to volume of cuboids. So X into pi r square into H1 is equal to length into breadth into height. So X into pi into 0.875 whole square into 0.2 is equal to 5.5 into 10 into 3.5. So X is equal to 5.5 into 10 into 3.5 into 7 by 0.875 the whole square into 0.2 into 22. So here also you can cancel. At last what we get? 400. So the number of coins melted to form such a cuboid is what? 400. Now the seventh question. A cylindrical bucket 32 centimeter high and with a radius of base 18 centimeter is filled with sand. This bucket is emptied on the ground and a conical heap of sand is formed. If the height of the conical heap is 24 centimeter, find the radius and slant height of the heap. So height of the cylindrical bucket is equal to 32 centimeter. Radius of the base of the cylinder is equal to what? 18 centimeter. Now, the volume of the sand in the cylindrical bucket is equal to pi r1 square h1. So height of the conical heap is equal to h2 24 centimeter. Let the radius of the conical heap is r2. So volume of the sand in conical heap is 1 by 3 pi r2 square into h2. According to the question, the volume of the sand in the cylindrical bucket is equal to volume of the sand in the conical shape. So pi r1 square h1 is equal to 1 by 3 pi r2 square h2. Now pi into r1 18 square into 32 is equal to 1 by 3 pi into r2 square into 24. So we need to find out what r2 square is equal to. Cross multiply 3 into 18 square into 32 by 24. Now 3 and 24 cancel. Okay, then 8 and 32 cancel. Then after that 18 square into 8 and 4 32 cancel 4 times. So 18 square into 4. Now R2 we need to find out 18 into 2 which is equal to 36 centimeter. Next one, the slant height also we need to find out. Its equation is what? Square root of R2 square plus H2 square. That is root of 36 square plus 24 square is equal to square root of 1296 plus 576, which is equal to 1872. Now then we can multiply prime factorization, put it, and at last what we get? 144 into 13 inside the square root. So we know the square root of 114 is what? 12 into root 13 centimeter. Now the next one question. Water in a canal 6 meter wide and 1.5 meter is flowing with a speed of 10 kilometer per hour. How much area will it irrigate in 30 minutes? 30 minutes if 8 centimeter of standing water is needed. Now what are the conditions given? Canal is in the shape of a cuboid, we know, where breadth is given 6 meter, height 1.5 and speed of the canal 10 km per hour. Length of the canal in 1 hour is equal to what? That 10 km. Length of the canal in 60 minutes, 1 hour is what? 60 minutes is what? 10 km. Length of canal in 1 minute is equal to 1 by 60 into 10, which is equal to 30 by 60 into 10, which is equal to what? 30 and 60 cancel 2 times. 10 and 2 cancel 5 kilometer. Same as 5000 meter. Now volume of the canal is equal to length into breadth into height. So which is equal to 5000 into 6 into 1. Now volume of the water in the canal is equal to volume of the area irrigated. So volume of the water in the canal is equal to area irrigated into height. Now 5000 into 6 into 1.5 is equal to area irrigated into 8 by 15. Now area irrigated is equal to what? 5000 into 6 into 1.5 into 100 by 8. So at last what we get? 5,62,500 meter square. Now area irrigated is equal to, we need to change that into hectares. So divide by 10,000, then which is equal to 56.25 hectares. Now the last question. A farmer connects a pipe of internal diameter 20 centimeter from a canal into a cylindrical tank in her field, which is 10 meter in diameter and 2 meter in depth. If water flows through the pipe at the rate of 3 km per hour, in how much time will the tank be filled? Now, the internal diameter of the pipe is 20 centimeter, which is what? 20 by 100 is equal to 1 by 5 meter. Internal radius is what? Half of that diameter, which is equal to 1 by 10 meter. Now rate of flow of water, it is given 3 km per hour. So change that into meter per hour, that is the 3000 meter per hour. Let the pipe take T hours to fill up the tank. So volume of the water that flows in T hours from the pipe is equal to area of the cross section. What is that? Since it is a pipe, so area is what? Pi r square. So area of the cross section into speed into time is equal to pi into r square is what? 1 by 100. So 1 by 10 square is 1 by 100. Now into speed 3000 into time t. Now the diameter of the cylinder is equal to 10 meter, depth is equal to 2 meter, volume of the tank is equal to pi r square, which is equal to pi into 5 square 25 into 2, which is 50 pi meter square. Now the volume of the water that flows from the pipe in t hours is equal to volume of the tank. So 30 pi into t is equal to what? 50 pi. So t is equal to what? 50 divided by 30 hours. Now change that into minutes. 50 by 30 into 60 minutes. Now you can cancel 60 and 30 two times. Then 50 into 2 is equal to what? 100 minutes. So the last time is equal to what? How much time will it take to fill the tank? Is equal to what? 100 minutes. Clear, students? Thank you.